Welcome everybody. So today we are going to talk about yet another motion quantity. This one is called acceleration. And to think a little bit about it conceptually, we're going to imagine some situations that you've probably seen in your everyday life. We can start by remembering that we've talked a lot so far about velocity, and we've seen a fair number of situations where the velocity of an object is constant. I can think about something like this as being a good example of constant velocity. But we've also seen some examples where the velocity of an object is not constant, and you can probably think of many in your everyday experience. I can think about situations where I have the ball moving around in the air, or just sort of if I move it at some obviously non-uniform motion. I can think about my car driving on the road. As long as I'm changing speed, then I'm going to have an example where I'm not moving with constant velocity. And all of that falls under the umbrella of acceleration, which is the physics term that we'll use whenever there is a change in the velocity of our system. We're going to start by giving a definition for acceleration here, and we're going to build that definition to be parallel to the definition we had for the velocity by defining the acceleration to be the change in the velocity of an object divided by the change in time. So again, very similar to how we define velocity as the change in position divided by the change in time. And just like we did for velocity, what we've really defined here is the average acceleration. Again, we can think about that very similar to the average velocity being the change in position divided by the change in time. Now you can see that acceleration, like other quantities we've seen so far, is a vector quantity. And it's related to the vector change in the velocity and the scalar change in time that elapses. The other thing that we can do, again, very parallel with what we did for the velocity, is we can shrink our time interval down to be very small, replace these deltas with little d's, and what we have is suddenly an instantaneous acceleration that I could write as a function of time as something like dv divided by dt.